This is the complete guide to split air conditioner installation and working system in detailed 3D animation. A split AC has two main parts, the indoor unit and the outdoor unit. Both units are connected with copper pipes, drain pipe, and electrical wiring. Let's first understand the indoor unit parts and how they work. Then we'll explore the outdoor unit and complete installation process. This is the indoor unit front panel. Air filters clean dust before air enters the system. The evaporator coil absorbs heat from the room air. The blower pushes cool air back into the room. The room temperature sensor monitors indoor temperature. The pipe sensor protects the coil from freezing. The PCB controls all indoor functions. The swing motor controls airflow direction. Condensed water collects in the drain tray. Drain pipe removes water outside. Low-pressure refrigerant gas enters the evaporator coil. Warm room air flows across the cold evaporator coil. The refrigerant absorbs heat from the air. As it absorbs heat, the refrigerant evaporates completely. Moisture from air condenses into water droplets. The condensed water collects in the drain tray. The blower pushes cool air back into the room. The room temperature starts to decrease. The refrigerant leaves as low-pressure warm gas. It now travels back to the compressor to repeat the cooling cycle. Refrigerant is the cooling gas inside the system. The compressor compresses low-pressure gas. Compression increases temperature and pressure. The hot gas moves to the condenser coil. Outdoor fan removes heat from refrigerant. High-pressure hot gas enters the condenser coil. The outdoor fan removes heat from the refrigerant. As heat is released, the refrigerant begins to cool. The refrigerant changes from gas into high-pressure liquid. It now becomes a high-pressure liquid. The liquid refrigerant moves toward the expansion device. The capillary tube restricts refrigerant flow. Pressure suddenly drops inside the capillary tube. This sudden drop causes rapid cooling. The refrigerant becomes a cold, low-pressure mixture. It enters the evaporator to absorb room heat again. This pressure difference makes continuous cooling possible. The refrigeration cycle works in a continuous closed loop. Compressor, condenser, expansion device, and evaporator are the four main components. This cycle repeats again and again to keep your room cool. This is the outdoor unit. The compressor is the heart of the system. In inverter models, PCB controls compressor speed. The condenser coil releases heat outside. The outdoor fan helps cool the condenser. This is the capacitor inside the outdoor unit. The capacitor stores and releases electrical energy. It helps the compressor and fan motor start smoothly. In many models, a dual capacitor runs both compressor and fan motor. This is the expansion device in the system. It controls refrigerant flow into the evaporator. It creates a pressure difference in the system. These are the service valves. Technicians use them for gas charging and pressure checking. They control refrigerant flow between indoor and outdoor units. These are vibration pads under the outdoor unit. They reduce noise and vibration. Proper mounting ensures safe and stable operation. Each outdoor component plays a vital role in cooling. Together, they maintain pressure, heat removal, and continuous cooling. Step 1. Select proper indoor unit location. Drill a hole for piping and wiring. Fix the wall bracket securely. Mount the indoor unit. Prepare copper pipes with proper flaring.
Proper insulation prevents cooling loss and condensation.
All pipes and wires are bundled together securely. Connect wiring correctly according to terminal markings. Indoor and outdoor wiring must match exactly. Drain pipe must have a proper downward slope. Incorrect slope can cause water leakage inside. Outdoor unit needs proper airflow clearance. Ensure the unit is level and stable. Vacuuming removes air and moisture from the system. Proper vacuum ensures long compressor life and better cooling. Vacuuming removes air and moisture from system. Release refrigerant into the system. Check for gas leakage carefully. Turn on the AC. Confirm proper cooling performance. Now the system runs in a continuous cooling cycle. The room becomes cool and comfortable. This was the complete split AC installation and working guide. Subscribe for more AC repair secrets and tips.
Drop your questions in the comments. See you in the next one.
If you're enjoying this, hit like, subscribe, and drop a comment below. Your support helps us make more great content.